The Friday class we had, I guess I was there.
No, 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 no. That was different. Friday, you didn't have the class with me. Physics class wasn't there. The class was with the other two students, Lubna and Kutsia, that batch. Friday, we didn't have the class. But did you attend this one? We discussed the discharging of cell, charging of cell, and all this part. No, you weren't there. Safina, you were there, I remember.
Class was Thursday.
Okay, Thursday when you have attended. Yeah, Thursday when you were there, I wanted to know about this. Okay, no problem. This was complete. Safina, just tell me in the last class, you took the screenshot of this page, no? As I remember. Okay. So one thing that I wanted to discuss, which I couldn't discuss in the last class, was that few questions can come. So I think, Safina, probably this should be our last class from this one, because magnetism you've already attended, and let's see, then your backup will be done. Huh? See, from this, I wanted to tell that whenever the graph is plotted, let's say this is V, or in fact, I'll say I versus V graph. Or you take this, the exact graph, if I'll take, this is V versus I, let me take V versus I. If we take V versus I graph here, okay. Now for V versus I graph class, the graph will, this question has come in the exam also, that what kind of graph will be plotted. See, they are definitely proportional to each other, but there's a negative sign. That's why the slope will be negative. V, we know voltage is directly proportional to the current. According to which law? Ohm's law. So this is the rule. But here they will be, the graph will be plotted like this. So whenever you are asked to do even, you have to. Now see, if I say this equation, V is equal to E minus IR. Now I can write this as minus IR plus E. This can also be written minus IR plus V. Or I can say V is equal to minus R into I plus E. Now look, if I write the equation y is equal to mx plus c. If I write down this graph, y is equal to mx plus c, just compare. See, why am I writing this? What is y is equal to mx plus c? This is the equation, linear equation. This is the equation, linear equation. This is the equation of the graph whenever linear equation is present. Okay, so y is equal to mx plus c. Okay, so here, see, y means what is there on the y-axis. What is there on the y-axis? Potential. So I think we're getting it right. Now, x-axis. What is there on the x-axis? Current. This is there on the x-axis, right? This is the slope. M stands for the slope. In the graph, M stands for the slope. So here M is equal to minus R. Means this is a question from the board exam. That's why this was a recent question, a very recent question. That's why I've written it separately. So they say slope of the graph is what? This is the slope of the graph is given by the internal resistance. Minus R is nothing actually. I hope you know. Resistance can never be negative. So minus R means you have to take its modulus because that doesn't make any sense physically. So this is the internal resistance. And C is the y-intercept. Y-intercept means this part. How much y-axis is being cut by the graph. Okay, this is the y-intercept. So what is the y-intercept? The maximum value is the terminal potential difference, that is V. But this value is the EMF. So y-intercept will be EMF. So if sometimes the equations are given to you or anything, please relate it with it. C is the y-intercept. Okay, C is your y-intercept means something that is getting intersected. Intersection, both are the same terms. So using this equation, you have to write this. Okay. So I copy down this one. Now see, I'll just tell you a few things, what all things we have to discuss from this chapter. Series and parallel and then combination. Combination of cells I'll discuss first in detail because a little bit of series and parallel we have already done. But see, I'll be discussing things. Now I'll be focusing on directly the questions part and all, so that this chapter is more or less completed in today's class. I'll try to complete the maximum portion of it, so that just in case if it is needed, Safrina, Wednesday would be your last class then. Okay, so please write it. Okay, I think it is completed. Okay, Anisa has also joined. Anisa, from the next topic, try to understand because this is almost done. So you can see series parallel combination of cells. Yeah, see this part. Safrina, Halima, and Anisa, pay attention from the series and parallel combination in the cells. Understand the cells properly because the resistor part is easy. Means after studying capacitance, we'll not at least have to do the basics. When is the potential constant? When is the current constant? Anyways, cells are connected. With the cells, resistors are connected. Okay. When you see the cells are connected in series, equivalent EMF and equivalent resistance, just add them all. E1 plus E2 plus E3 and all like this, just add it. Similarly, R1 plus R2 plus R3 like this, just add it. For series combination, this one is for the series combination. I'll write it also. This is for the series, though it's visible clearly from the figure also. Now see current, here you will calculate your RE and this will give you your E equivalent. And current will be calculated in the same manner. If external resistor is present, you will use E equivalent by capital R plus small r equivalent. The difference is that only equivalent part will be used. Okay. So 10-volt battery is there, 1 ohm is there, 5-volt, 2 ohm, 15-volt, 2 ohm, and all are present. It says calculate current through each cell. And then it says terminal potential difference across 10 ohm resistor. Current through each cell, for that, the equivalent EMF we'll have to calculate. All of these are in series, we'll add all of these. 10 plus 5 plus 15, this is 30 volt. And R equivalent will be 1 plus 2, that is 5. And capital R is 10. So current will be equal to E equivalent divided by R plus small r equivalent. So current is equal to 30 by 10 plus 5, that is 30 by 15, which is equal to 2 ampere. Okay. Second is terminal potential difference across 10 ohm. Now, terminal potential difference, you know how to solve. V is equal to E minus I into small r. Across 10 ohm, it said. So, EMF across 10 ohm. 10 ohm? Okay, this one, external resistor. Terminal potential difference across the external resistor, it is asking. That is simply I into capital R. That also you can do. We have already discussed now, terminal potential difference is basically the current across the external resistor. So simply no need to use this equation, though this will be lengthy. This will be simply I into capital R. I is 2, R is 10, that is 20 volt. So that will be 20 volt over here. So E equivalent is 30 volt here. This will be distributed like this. We have the 20 volt present. Fine. Is this question fine?
Yes, sir.
Okay. E equivalent. Okay, one more thing. If the cells are reversed, so E equivalent will be whichever is the reversed one. Just put a negative sign. Means usko add nahi karna. E1 plus E2 plus E3 like this. You are adding all of it. Whichever cell is reversed, just put a negative sign. Means properly subtracted in case of EMF only. Resistance can never be subtracted. Resistances are never negative also. So resistance will be the same, but just be careful with it. One question recently came parallel combination. So for parallel, I'll directly tell you the formula. You don't have any derivation from this. Just write down the question, take the screenshot of this. I'll tell you the formula of the parallel after this. Okay. And then before the resistor one, I'll discuss the identical cells. And the identical cells is also very important topic. Please go take the screenshot of this. Okay, see, for the parallel connection, in this cell, I'll tell you here itself, not written here, I'll write it myself. For the parallel connection, see, when the cells are connected in parallel, and the question also has come recently, I'll share the question also with you. If the cell, see, this is the resistor connected, this is the cell connected, resistor connected, again, cell connected, resistor connected, like this. E1 is there, R1. Now these are unidentical. Okay, these all are unidentical cases. Means EMF will be different, internal resistances will be different. E3, R3 like this they are connected. So see, formula of E equivalent will be E1 by R1 plus E2 by R2 plus E3 by R3, whatever it is, divided by 1 by R1 plus 1 by R2 plus 1 by R3, whatever is the number like. And for R equivalent, this is 1 by R1 plus 1 by R2 plus 1 by R3 like this. This is how we take it in parallel combination for the normal resistors also. When you study for the resistors, this won't be difficult to remember, but this you have to remember, E equivalent one. Because it is lengthy, and especially for two cells, you should remember this. This is for the parallel one. In the exams, till now, not more than two cells have come in the parallel. This also I'll tell you. Just write this quickly and then we'll discuss the identical ones. Okay, these are unidentical. These are different one. Don't use this for it. I'll discuss the unidentical one. There we have lots of things. Just copy down this one and let's complete this.
Done, ma'am.
Halima, what are you asking? Ray optics class you're asking. Ray optics will be on Saturdays, no? On Tuesday and Thursday. In that batch, we'll be doing the ray optics, no? This is the backup one.
Okay.
Okay, Monday and Wednesday, because it will be very difficult for you to attend the backup also on the same day. So here you will have the backup classes, means current electricity will more or less be over this week. Magnetism, only first four chapters take time. We have started everything from the scratch and from this batch also. So whatever time it takes to you, other students also that are there in this batch, like Oishi is also there. She's also a new student. She'll also be attending both the batches, new portion from the next batches and the backup from this. Okay, Halima. So you attend this batch also. This will benefit you. Everything is going very fast in this batch. Most of the things I don't even give you time to copy. It's just that a little bit idea you should have. Okay.
Okay.
So see, when the cells are identical, see, in your exams, you have unidentical cells also and identical cells also. And in unidentical cells, you have series and parallel combination, which we have discussed. And those questions only come. And from parallel, recently a question has come, especially for two cells. Okay, this much is there important from that part. From identical cells, you have three things. You have series combination, you have parallel combination, and then you have mixed grouping also in this. So this is how you should study the cells together. And then finally the resistors. Resistors topic is endless and more or less class. Remember one thing, once the ray optics is done in the batches, and in every batch ray optics has been started, even in Safrina, your batch also. I think Halima is there in the same batch only. Halima, you're attending the class on Tuesday and Thursday, no?
Yes, ma'am.
So you both are in the same batch only. And Anisa is also there in the same batch. Yeah. So in your batch, ray optics has been started. We'll give a lot of time to ray optics because it's a very tough chapter. Wave optics will take a less time. And then the syllabus will be very fast because the chapters are very small and very easy. And I'll tell you, most of the notes are written. Like for dual nature, for the entire modern physics, atoms, nuclei, and dual nature, I'll be already providing you the notes in advance, written notes in advance. So you won't actually have to waste time in the classes and everything. One or two classes are sufficient for every chapter. So once all the portions are completed, because we have to prepare you for your pre-boards, at least you should score a good marks in the pre-boards, and pre-boards are very important in 12th class. During that time, once the syllabus is done, after a week or so, when your pre-boards are in the middle or they are towards the end, we'll have proper revision classes. Revision classes means separate classes will be there with your respective batches only, or maybe one or two students will be shifted here and there maximum. And those revision classes go on proper. You will get a schedule. Your weekly tests, revision tests will be conducted in the board's manner. So if in those classes, we'll be doing the practicing part more. Not just you, the other students also will be doing who are studying since March or April. They will also be studying along, and you all also will be studying here along. So whatever practice part that we are not able to do in these backup classes, so don't worry about it. In the revision classes, after every theoretical part, because we don't have to study everything in detail, derivations and everything, just it would be a quick revision, and more we'll focus on every question. Numericals, conceptual, previous years, predictable questions, then revision tests, and then some of the assignments if they are left, assignment questions and all. So it's for all of you, Nisa, Safrina, and Halima, that even if you're worried about the backup classes being fast or anything, just in case. So right now, at least study it so that you have some idea, and whatever doubts you have, and whenever you sit to self-study, it will benefit you. And for the numericals practicing, don't worry, we have proper revision course schedule. You will get it in the month of December. Okay. Is it clear to all three of you?
Yes, ma'am.
Okay. So coming to the series combination, here EMFs will also be the same, internal resistance will also be the same. So when you take the equivalent EMF, E plus E plus E plus E like this, if you take, so let's say n number of cells are identical, okay? N number, the N means number of identical cells, number of identical cells. So this will be N times EMF, okay? Similarly, when you add all the internal resistances, it will be N times the internal resistance. All right. So see, NE is there, NR is there. Now current is present. So see, what do we do? EMF divided by EMF is NE divided by external resistor. Let's say this is R. Now class, one thing, when I say R, it doesn't mean one single resistor is only connected. Only one external single resistor can be connected. See, if you remember the previous classes, what did we discuss? Internal resistances are associated with the battery, the cells, right? The internal, I even drew a diagram about the electrolytic solution and all, if you could recall. So external resistor means that is the resistor which you are connected from your end in the circuit. These are not provided by the cells. You are deliberately connecting these resistors in the circuit. Okay, this is what is meant by the external resistor. Now, if I wish, if I want, according to the needs, what I can do, I can connect multiple external resistors, some in series, some in parallel, and finally I can get a final R equivalent. So whatever will be that final R equivalent, no, of all those multiple resistors, that is this capital R. Okay, this is not just a single. Okay, a single resistor can also be connected. If I just have one single resistor, I can just connect it in that circuit. That will also do the function well. Here, capital R means your external resistors are present. External resistance can be 1, 2, 3, 4, whatever, but finally you just have to put R equivalent. Got it? This point, what I'm trying to say.
Yes, ma'am.
Okay. Now, regarding this will be N small r. Now, here two conditions are possible in the series. If external resistor is very much greater than internal resistor, R plus NR is almost equal to capital R, we can say this, all these denominator means all of this will be equal to capital R only. It's like I have 1000 ohm and I have 1 ohm. 1000 ohm plus 1 ohm, what will it affect in my answer? It will almost be equal to 1000. So in such a case, forget about this line, consider series combination. This I'll explain you later. Just right now, ignore this. Just focus on this part which I'm telling. I will be NE divided by, now the whole denominator can be just written as R. This much is fine.
Yes.
Anisa, why are you not responding? Halima and Safrina are only giving response. I am not even asking any question right now. At least respond with a yes or no. Are you understanding something or not? If you want me to repeat any part. Please, Anisa, be interactive in the class. I have said this multiple times. If internal resistor is greater than external resistor, then it will be equal to NR. Means you can neglect this capital R. It's like NR's value is almost equal to 1000 and external resistor is just 1. So in that case, what we'll say, I is equal to NE divided by NR. Okay. Now here what will happen? NN will be cancelled. I is equal to E by R. This part is fine. Till this much series is done. Okay, now let's come to parallel. In parallel, equivalent EMF, I discussed with you in capacitor chapter when we discussed the equivalent capacitance that the net voltage will be the equivalent voltage basically in parallel combination doesn't change. Means voltages never change on branching. And I told you that this fact is valid for the parallel combinations of resistors as well, or it's not just resistors, it's capacitors, it's inductors or resistors. The equivalent potential that we take for the whole circuit, that is still equal to all of the potentials of the individual circuits present. Okay, so if I have 5 batteries connected with the same voltage E, my net voltage of the circuit will still be E. We won't add them, no, because voltage is not getting distributed that I'll add them to get the total voltage. If my total voltage of the circuit is 5 volt, each of the wires will have 5 volt. So if I add them, then it would contradict the fact because it will never be equal to that 5. So equivalent EMF, because it's a parallel connection, it will be just E. No need to multiply, divide or anything. But resistors you have to. 1 by R equivalent will be 1 by R plus 1 by R plus 1 by R. Like this, you will add them. Let's say in parallel connection, just to differentiate it, we are taking the letter M. M identical cells are connected. So if I have one cell, I'll say my R equivalent is 1 by R. 1 by R equivalent is 1 by R. If I say two cells are there, I'll say 1 by R equivalent is 1 by R plus 1 by R. If I say three R equivalent, cells are there, my R equivalent will be 1 by R equivalent will be 1 by R plus 1 by R plus 1 by R. Four cells, 1 by R plus 1 by R plus 1 by R plus 1 by R, right? So if M cells are there, means M times 1 by R. See, this is 2 by R. 1 by R, 2 cells, 2 by R, 3 cells, 3 by R, 4 cells, 4 by R, M cells, M by R. So can I say 1 by R equivalent is M by small r? So what is my R equivalent? R by M. Now let's put it in the value of the current. Now we can say current is equal to EMF divided by capital R by M, R plus R by M. Take the LCM here. MR plus small r divided by M. This M will go up. What is the equation form? Here we can say I is equal to ME divided by MR plus small r. That was NE by R plus NR. This is ME by MR plus R. Got it?
Yes, ma'am.
Okay, here also we'll have two conditions. If capital R is greater, so we will just write it as MR. So what will my equation be? This will be ME divided by MR. MM will be cancelled. I is equal to E by R.
Ma'am,
If small r, yes,
can you tell me once what does the M denotes for? I want to write
it
it.
denotes the number of cells that are connected in parallel, like one cell, then one more I've connected in parallel. Like N we took in the series, number of cells like this in the series. Here also number of cells in parallel, but just to differentiate for series and parallel, here we took N and here we are taking this as M. It means number of cells that are connected in parallel. Okay.
Okay.
And if small r is greater, see, this will be equal to ME by R. Now look class, what does this line mean, or what these lines mean actually, the both of these lines. Let's look at the first case where capital R is greater than small r. Now be attentive and answer one thing class. Look here. I is equal to E by capital R here. Let's see the series one. In the same case, we are getting NE by R. So that was E by R. This is NE by R. Series one is greater or parallel one is greater? Yes, class, which is greater? Just compare. Yeah, Safrina. Say? Series. Series, of course. Why are you underconfident in this? Yes, you're right. Of course, N times E by R, and that was just E by R. N times will definitely increase the value. So see, if I have external resistor greater than the internal resistor, I'll definitely have the current more. Now, our purpose in every circuit is to get the maximum current. You'll always want to prefer a maximum current, no, in your circuit, in an ideal condition. And when you require a less amount of current, for that you already have a rheostat or a resistor. That's a different case. When we reduce the current or modify the current, that's a special case. But in general, we always try to get maximum current because that's how it will benefit us. Low voltage, low input, and you're getting a maximum current. So out of the series in parallel, I think this will be the maximum value and E by R, while in the parallel, it was just E by R. So if capital R is greater than small r, I think we should prefer series combination. That's what has been written. Consider the series combination because numericals have come based on this concept. I'll show you a question also. Numericals have come. If we say this case, this is E by R. But in parallel, in the second case, this is ME by R. Of course, this is greater. It is maximum value. So we'll prefer the parallel combination. Am I clear?
Yes, ma'am.
Okay. So this question I want you to answer. Yes, just note down this one, identical cells part.
Hmm? Peluru. Peluru.
Yes, class, tell me one thing. In both of these cases, this external resistance of 0.05 ohm is there and internal resistance 1 ohm is present. So, and here the external resistance is 100 ohm. So just tell me one thing, in the first one or in the second, just a minute, class. Just tell me one thing. External resistance or internal resistances are present. Which one will we prefer for the first one or the second one?
Ma'am, your voice is not clear.
Is it better now? Not coming.
Yeah, ma'am.
Now check, is it better? Safrina, Halima?
Yes, ma'am. It's better now.
Okay. See, I was saying 8. I hope you've written the question by now. Just
Yes,
tell
ma'am.
me one thing, class. In the first case, which we'll prefer, series or parallel? This was my question. This is what I was asking to both of you, two or three of you actually. Anisa, you're also there. Respond. Which one we'll prefer? Huh?
Series?
What, Halima?
Series?
Series. And the second one, see, how do you check all these things? You check whether capital R is greater or small r is greater. Okay. See, this is 1 ohm given, this is 100 ohm. This is 1 ohm given, this is 0.05. You have to compare the external resistor with the internal resistor. That's why we saw the cases. Now, in series, what did I tell you? When you have to prefer the series combination, look, in the first one, this one. Here, when capital R was greater, then only we prefer the series one. In the first part, you are given 0.05. How will you prefer the series one then? Got it? Check the external and internal resistor. Compare them. You are comparing 1 with 0.05. So, small r will be greater than capital R. Getting my point? So, here I is equal to ME by MR plus R. You put the values that you can calculate later. Identical cells are there, so M will be equal to 8 in this case. Second is 100 ohm and 1 ohm. So obviously you will prefer the series combination, right? So this is the solution to it. One more thing I have to tell you about the mixed grouping part. Write down the solution of this quickly. Question लिख लिया है सबने? Others
Yes, ma'am.
also? Anisa, please respond. You have to unmute yourself and answer. Why only Safrina's camera is open? And it's not just that in this batch she is active. You all have to be active. Without seeing her camera is open. And plus, this is the rule over here. You have to open the videos. I also teach with my camera open. So this is just for the interaction purpose. But still, at least respond with a mic also if there's a trouble with opening the camera. Write this quickly. Mixed grouping I have to complete today. Class done. Does also? Halima, Anisa? Okay. See, mixed grouping means if I have, is it visible screen to check?
Yes, ma'am. It's visible.
Screen is visible? Okay. See, mixed grouping means I had one case where the cells were connected in series. Now, if I have those series cells and I connect them in parallel, then that is known as mixed grouping. So in that case, what happens? First, you solve each of the row. Each of the row will give me NE and NR as discussed in the series part. Remember, each will give NE and NR. And then you have, it's like you have NE, NR, NE, NR connected in parallel. So NE and R parallel will be what? Equivalent will still be NE because this is now in parallel. The way we got that NE, this will be NE, right? And NR will be C. 1 by NR, it's you solve this part. 1 by NR plus 1 by NR for 2, so 2 by NR. 3 cells, 3 by NR. M cells, M by NR. So R equivalent will be NR by M. This much is clear? Okay. So
Yes,
here
ma'am.
when you put I is equal to E equivalent by R equivalent plus R, this is NE by capital R plus NR by M. So you take the LCM, M goes up, so this becomes M in E divided by M capital R plus NR. This is what we have, and if your MR and NR they are equal, this is known as maximum power transfer theorem. Means your MR is equal to NR. So this is it, what you need to remember now. Okay. And see, now we are just left with a series and parallel combination of resistors. So Wednesday would definitely be the last class, and I'll try to start magnetics also for the other students. So Safrina, Wednesday will be the last class. You will not have to attend the entire class, I hope, because series and parallel basics one will be just going through very fast. Few things are there that I have to tell you. Infinite resistors, those circuits come Wheatstone bridge, Kirchhoff's law. These are exclusive for this chapter. Okay, that I'll do in the next class. You all take the screenshot of this. You can write it later because one more class will be just started now in a few minutes. You just take the screenshot.
Are derivations there for Kirchhoff's law?
Derivations are in there for Kirchhoff's law. Derivations are in there, but questions are there. You don't derive anything. It's just a law. Statement is there. There's no formula for it. There are rules for it. So derivation we'll be doing using Kirchhoff's law. We'll derive Wheatstone bridge. That derivation is there, which I have to do. Okay. So Wednesday, let's come to conclude this chapter. So for those students who magnetics part is left, that will be done. Most of you are done with it. I think Halima has to study then EM waves.
Done, ma'am.
Take this last part as well. Let me know done.
Yes, ma'am.
Done? Okay. So Wednesday we'll have the last class for current electricity. And just attend the class because we'll be practicing more on the numericals part rather than the theoretical part. Heating is also there. Heating also won't take a time. So I think next class we'll complete this. Okay.